All right, so today's video is focused on polynomial transformations. I know we've done transformations a couple times this year, so this is just another review, and it actually isn't too different. So if you like transformations before, you'll probably like them again. So there are three main polynomials that we are going to look at for transformations. The first is quadratic. So draw a little xy axis here. And we know quadratic is y equals x squared. And a most basic quadratic looks like this, right? It has a U shape. That's a quadratic. Now we have a cubic. So that's what we call when we have something raised to the third power. So draw a little xy axis. And a cubic looks like this when we draw it. Nice and pretty. And then we also have a quartic. We're not going to see these as much, but we do want to show you that transformations can apply to any polynomial. So when it comes to a quartic, it kind of looks like a U shape. It just gets wider faster. So it's kind of like an elongated U. And then we have our transformation rules. So these are going to be the same as our other transformation rules. So we're just doing a little bit of a refresher here. So if we have a function, no matter what it is, and then we are adding or subtracting something outside of that function, that's what we call a vertical translation. Okay, so we're basically moving it up when we see something that. So it's going to moves up or down. So if we see something like, we'll say f of x plus 4, that's going to move up 4 units. And if we see something like f of x minus 3, that's going to move it down 3 units. Then we have horizontal transformations that happen on the inside, so either inside the quadratic or inside the cubic. So that's going to look something like this. X minus, we'll say C on the inside. And so this is going to move it left or right. And it always moves it the opposite of what we think. So if we have f of x minus 2, that's going to move it right 2 units. And if it's a plus, so if we have f of x plus 1, that's going to move it left 1 unit. Okay, so that's our translations, where we're picking it up and we're moving it either right or left or up or down. Now we look at our vertical stretches and compressions. So that's when we multiply by a number outside of our function. So if we multiply by a number like in front of the parentheses, in front of everything. And this is going to like stretch or compress. So we can think about it as like changes how wide it opens. And we're always comparing these numbers to 1. So if a is greater than 1, then that's a stretch. And if a is less than 1, then that's a compression. Okay. We also have horizontal stretches and compressions. So that's when it's being multiplied by a factor on the inside. So it looks something like this. Say f of bx, so inside whatever parentheses we have going on. And this also changes how wide it opens. And again, we're looking at those stretch and compression rules. So B is greater than 1, and B is less than 1. So B is greater than 1. It's going to kind of do the opposite. It's going to compress it. And B is less than 1. It's going to stretch it. But we don't have to worry so much about horizontal transformations. We need to know what they are, but we're mostly going to be working with vertical translations. And then the last, vertical stretches or compressions. The last one that we need to know about is a reflection. So whenever we see a negative sign in front of our function, this means that it is reflected over the x-axis. And there's not really any different ways to do it. If it's opening up and then we reflect it, then it's going to open down. So same thing. But now that we know and are reminded of our different transformations, we can start to put them into practice in our little descriptions here. So if we are writing equations from descriptions, we're going to look at, we're given our parent function. This right here is what we call the parent function. And then we're given some changes to that parent function. So we're going to do whatever it says to that equation in order to make the shift happen. And you can always check this with Desmos if you're not sure how it ends up moving, or you would maybe want to see it for yourself to make sure you get it right. So we're shifting this cubic function to the left 7 units. So if we're shifting it to the left, I know it's going to be a change kind of inside, like we talk about, and it's opposite, right? The opposite sign of what we think when we're going left or right. So we are going to do x plus 7, and that's all we have to do for our new equation. And number 2 here says we are vertically stretching f of x equals x to the 4, so that quartic function, by a factor of 4. And we're vertically stretching, so that tells us that we want our number to go in front of the whole thing. So we're going to have f of x equals 4, x to the 4th. That's what it would be to vertically stretch it. Okay. 3 says that we are going to reflect about the, and it should say about the x-axis. So the only way we reflect is by using that negative sign. So that negative goes in front. So I'm going to do the same thing and put a negative right there. So f of x equals negative x squared. Perfect. And then for 4, it says we are shifting this function that we already know. We're going to shift it up 2 units. So if it's going up 2 units, we know this part has already moved it some type of way. So we're going to add 2 to this number to shift it up. So f of x equals x squared, and then negative 9 plus 2 would make it negative 7. So we don't just have to transform parent functions. We can also transform functions that are already there. Okay. And now for 5, we want to vertically compress g of x by a factor of 1 over 3. So when we vertically compress something, we are multiplying the whole thing by it. So we're going to do a little multiplication in front there. And we know that that would give us 15 divided by 3, which is 5. So that new compression factor would be 5, and then x to the third. Okay. And then now we're translating f of x right 6 units. So we know that right 6 units would mean -6. And if we're already at -3, we need to subtract -3 from -6. So that would give us f of x equals x minus 9 to the 4th power. Perfect. So that's a little bit about how we kind of utilize the transformations to write our own equations. And here, we want to identify transformations from the equations. So we're going to use a little verbal description here just to label what we see. So I know that this is a cubic parent function. That doesn't really change the transformation process, but it's a good thing to practice noticing. So let's look at this negative that's in front. According to our table above, we see that a negative is going to reflect over the x-axis. And then this 5 on the outside is going to move it down 5. So if we weren't totally sure about this and we wanted to just confirm, we could go pull up Desmos. And there's 2 things that we want to graph here if we're going to check our work on Desmos. The first is that we're going to graph the parent function, so without any transformations. So here I'm going to graph y equals x to the third, because that's my parent function. So I see my red line, and then I'm wanting to know what transformations are happening to that red line. So if I then type this new function, perfect. So the blue line is what I'm looking for. And let's see, it did flip it the other direction. Perfect. And then I also see that this point right here in the middle moved down 5. So I accurately predicted the transformations that would be happening. And we can do that anytime that we're just not sure. So let's look back at number 8. We have a lot of stuff going on here. So the first thing I see is this 2 that's in front. If we go back to our table, when it's multiplied by a number in front, that means we're vertically stretching it. So we would say vertically stretched by 2. Okay, the -4 on the inside is going to move it to the right or the left. It's kind of opposite of what we think. So instead of moving it to the right or into the left, we're moving it to the right 4 units. And then lastly, that 6 is moving it up 6 units for us. Okay. And then here we have 9. If my thing wants to move over. There we go. And here we also have a couple things happening. This is a quartic function. First thing I see is the negative. So I know that it's going to reflect over the x-axis. I also know that that 1/4 is going to vertically compress because it's less than 1. And then I move it left 1 unit. So that is how we look at transformations, or look at an equation and identify the transformations that occur. So now we are going to look at some graphs, and so we want to describe the transformation that occurs in each graph from the solid line to the dotted line. So that's important for us to remember. And we want to describe it, the parent function, and the original equation. So this is going to be the solid line equation. And then the new equation, which is the dotted line equation. So if we just want to talk about what's going on here, I always want to pick a point to compare. So that looks like a good point, that middle turning point is a good one to compare. So I want to look at what do I have to do to move this point here, and maybe I'll even switch my colors. So to move the red point to the blue point, right? What does that take to go from here to there? Because those will be the same transformations that are happening all over. So I can this is the way I view it. You can view it another way too, but it kind of shows us how it's moving. So I think that it's going to go up 2 units because I have to move it from the red up to get to the blue. And oh, it's not even 2 units because I look here, all of my numbers actually go by like 2 blocks at a time. It's just really zoomed in. So instead of going up by 2 units, that would just be a number 1. So I'm just going up by 1 unit. And then to move horizontally, or right to the left, I'm going right 2 units. So I know that this is an x to the third. So both of my equations are going to have x to the 3 in them. And first, I'm going to write the equation of the solid line. So if I know the basic is y equals x to the third, the normal point of the parent function is up here. Okay, that's our parent function. You can always graph it if you don't remember what it looks like. And from this turning point to this turning point, we're going down 2. So in order to show down 2 in my equation, I'm going to be subtracting 2 on the outside. So I could say f of x equals x to the third minus 2. Perfect. And then to go from my parent function to my other equation, I can see that I'm going down and I'm going to the right. So I'm going down 1. So that means I'm going to have down 1 on the outside, so minus 1. And then I'm going right 2, which is going to be x minus 2 on the inside. So I just labeled these different letters just to make them a little bit easier. So for this practice, it doesn't matter what letters I picked. I just picked f of x and g of x. But you could pick, any letter that you wanted to for those. Or the question might tell you specifically how it wants it labeled. So let's go ahead and look at our last example here, example 11. So this one, again, we're wanting to move from the dotted line to the solid line to talk about our transformations. So I'm going to pick this point right here and that point right there. So kind of talk about how they transformed. So to go from this point to that point, I didn't change how much it was up and down, but I did change how much it was left and right, and it was moved 2 units right. And then I can clearly see that it's facing a different way. So for this one, if it's going to face a different way, that means that it's reflected over the x-axis. Okay. So this parent function should look super familiar. It's quadratic. We've done a lot with quadratics this year. So we have y equals x squared. And then we need to create our dotted and our solid equation. So I'm going to do the original equation in red, and my normal parent function is like something like this. So if I'm moving this point from here to here, I see that I moved it to the right, and I also moved it up. So I moved it to the right 2 units, so that means inside it's going to be x minus 2, and then squared. Then I moved it up 1, so plus 1. And then let's use green this time, to get to my dotted line from my original, I'm doing even more movement. So I see I'm also going to the right, and I'm also going up, and then I'm changing the direction that it opens. So I'm going to have to flip it down. So flip it down, we know it's going to be a negative out front. I moved it right 4, so that tells us x minus 4 inside the square root. Or not the square root, the square. And then I still moved it up 1, even though it's in a different spot. Alrighty. So hopefully this was a helpful review on how to transform polynomials and showed you that we can do it no matter what